So hello everyone, this is lecture 23 for the mathematical physics, in which we started the differential equations. In the last lecture we started. Okay, so we did up to here, means we did the separable form, and we find out how to solve a normal differential equations. Now we take one more example like this. Question is given: dy by dx is this, y square by x, this is equal to sign, with y1 equal to 1, initial condition given, the range of x in which y is real and finite. So we have to find the range of x in which y is real and finite. So first of all we need to find the function that is in the form of y, then we can find the values of x and the range. Okay, so these were the option given. So first of all, let's solve. It will be y square this side dy, it will give you minus 1 upon y, and x dx this side 1 upon x dx, that will give you log x plus c. Using initial condition you will get c equal to minus 1. After substituting you will get this value, and from here you can find that y equal to 1 upon 1 minus log x. Now see, we can find the range of possible values of x, as it can't be negative because there is no negative in the log. So these two options are not in option. Okay, so just neglect them. Now we have two options, 0 to 3 or 3 to infinity. So if in it 0 is possible, so for 0 we know log doesn't exist for 0, it is not defined, so only D option is remaining, so this will be our answer. Okay, now let's see one more example. df over dx plus 2f equal to 3, and initial condition given, f0 equal to 0. Now try to solve, just use the separable method. 3 minus 2f will came out in the downside, df equal to dx. Now this is nothing but 1 minus 1 upon 2 log 3 minus 2f. If you differentiate it now, you will get 1 upon 3 minus 2f, 0 minus 2, it will cancel out, and you will get this again. Okay, you can solve it by substitution method also. Put 3 minus 2f equal to t, and that's how you can use df in place of dt, and you can solve it. And in the last, substitute again in place of t 3 minus 2f, you will get this value again. Okay, and here it will be x plus c. Using this condition we get c equal to minus 1 upon 2 log 3. Now this 3 minus 2f should be equal to e to the power minus 2x plus log 3. So e to the power minus 2x multiply e to the power log 3 will give you 3, because e to the power log x will give you x, that's why it is 3. Now from here you can find f equal to 3 upon 2 1 minus e to the power minus 2x. So question can be asked like plot this curve. Okay, so how you can plot this? So we know for x equal to 0 it will be, whole term will be 0, so it came out to be here. Now as x increases, so we see that it is exponential function. So at x equal to infinity it will be e to the minus infinity. 1 upon infinity will give you 0, so at infinity it will be 3 upon 2. So this curve will tends to 3 by 2. As it goes to x tends to infinity, it will tends to 3 by 2. So this type of curve you will get. So this kind of question can be asked in the exam. Now let's see one more type of problem. There is very less question asked from this topic, but you should remember this topic. Maybe this time question can be asked, and you can solve any type of equation. So if it is homogeneous equation, so you can reduce that to separable form. We just discussed the separable form. You can reduce this equation into separable form. How? So first of all, what is a homogeneous equation? So whenever you get something like this, where dy upon dx is something, and you have same degree on the numerator and the denominator side. Same degree in the sense I will tell you, where f and phi are of same degree. How? Let's take an example. 2xy y dash equal to y square minus x square. From here y dash, that is dy by dx, equal to y square minus x square divided by 2xy. Now it is of if we put the unit as lambda, then it will be lambda square lambda square. It will be numerator has lambda square something. So here also it is lambda lambda, it will give you lambda square. So it has 2 degrees 2 for both of them, and for this also. So if you have the same degree, then it will be a homogeneous equation. Now you can use the simple relation here, y equal to vx, then dy over dx will be, just use the product rule, v plus x dv over dx will be dy by dx. Now this will be our dy by dx, put it here, and so divide by x square this whole equation in the numerator and denominator. You will get y by x whole square minus 1, and in the denominator you will get 2 into y by x. So y by x is v, so you will get here this v square minus 1 divided by 2v. So this term equal to this. From here dy by dx is this, so it is here, and this turned out to be this. Now you can just separate this form. This form is separable in the terms of dv and dx. How? Just take v this side, you will get this. Now dx this side and x, and hold this v terms this side with the dv. So you can separate them like this. Now this is solvable. We know that this is nothing but log 1 plus v square, because it will give you this again, 1 upon 1 plus v square then 2v. So this integration is this, and it is minus log x plus log c. Now if you see that it came out to be this side, then 1 plus v square x, just substitute the values of v, means first take the 1 plus v square x equal to c, and now put the v equal to what we substituted earlier, v equal to y upon x. You will get this equation, and this equation is nothing but you can see it is the equation of circle. How we can turn it into the standard form? How? Just take cx on this side, x square plus cx plus y square equal to 0. Then you can turn x square plus cx into the complete square. How? First take the half c by 2 square plus then c by 2 square minus in the whole equation. Then you will get this kind of form. Now you can simplify this, you will get again this. How? X square plus c by 2 square plus 2 cx will give you cx, and plus c by 2 square here plus c by 2 square, they will cancel out, and you will again get this x square plus y square equal to cx. Okay, so this equation can be written in this form, and this is a standard equation for circle, where this inside terms represent the origin of the circle. X minus a square plus y minus b square equal to r square. That is a standard equation where a and b are center and r is the radius of circle. So from this equation we can see c by 2 is radius. So this differential equation, or this solution of that differential equation, is the family of circles. So just put the value of c and you will get different circles. For c equal to 2, your radius will be 1, and this origin will be 1 and 0. So your origin will be here 1 and 0, and radius will be 1. So that will be for c equal to 2, this will be your circle. For c equal to 4, you will have origin at 2 and 0. So this will be your origin, and radius will be 4. Radius will be 4 divided by 2, that will be 2, 2 to 4. So 4 will be your radius. See, 4 will be your radius, and so center will be here. Okay, so that's how you can draw these circles. Sorry, let me just correct it. For c equal to 4, you will have 2 to the 4, 2 as the radius. So an origin is 2, 1. So from here 2 radius will be came here. So this circle you will get. Okay, so these equations you can get, and different circles you will get. Now let's see one more example of homogeneous equation. So this will be given like this. So from here dy by dx is equal to this. Now you can see it has degree 2, and here also degree 2. So it is a homogeneous form. So divided whole equation with x square, you will get y by x square, y by x, and here also y by x and 1, and y by x equal to v. So you will get this equation, and again the same values, and now you can separate these forms. Take v this side, and whole v term with dv, and x term with the dx. So you will get this form. Now this will give you log x, and if you differentiate this, you will get 2v plus 1. So it will be log v square plus v, this integration. And from here you can see that v square plus 1 equal to cx. These will be multiplied, cx equal to v square plus v. Now substitute the values for v, y by x, so you will get this equation. So this is your solution. Okay, now let's see one more thing, that if it is not homogeneous, and the equation can be turned or reducible to the homogeneous form, this kind of equation. If you get this kind of equation, dy by dx equal to ax plus by plus c, capital Ax plus capital By plus c, these c are different, these b and a, and here b are different. This is capital C, this is small c. Now this kind of equation can be turned into the homogeneous form if you are getting something like this. How? Let's substitute x equal to capital X plus h, and small y equal to capital Y plus k. So from this second equation you can find dy over from both these equations you can find. Okay, so dy over dx capital X equal to dy over dx. This will came out to be this. Okay, you know how to do that. So these are both equal. So now we can write in place of dy by dx, we can write this capital dy by dx. So this is equal to this. So that's how you can check. Means if this equation is equal to capital Y equal to y minus k, then it will give you dy by small dx equal to dy by dx. And from this first equation you can see d small x divided by d capital X will be 1. Okay, so just multiplying these dx by dx and dy by dx, this will cancel out and it will give you 1 into dy by dx. So this will be equal to dy by dx. That's how you can find. Now just substitute these values here. So x equal to this x plus h, y equal to y plus k. So after substituting you will get this value, this kind of equation. Now you will see this ah plus bk plus c, and this capital AH plus capital BK plus C. Here A, B and C are constants, A, B and C are constants, and HK are variables, means HK are also constants, but you don't know these values, so you can find them. How? Just put this value equal to 0 and this equal to 0 and solve for H and K. Find the values of H and K. Okay, just substituting these values equal to 0 and find the value of H and K. Then this will be 0, this will be 0, and you will get this kind of form: dy over dx equal to ax plus by, ax plus by. Okay, this is capital A, capital B, this is small a, small b, and xy. Now dividing with y, you can get this form into the homogeneous form. Now this can be reducible to the homogeneous form because these will be 0, and this is this equation, this kind of equation you know how to solve. So there is special case: if this a upon a equal to b upon b is constant, means this ratio is same, then how you can solve? If this ratio is same, let's say 1 upon m, then dy by dx will be, means this ratio is same, then here a upon a equal to b upon b, then you can take something constant here and you will get this again upper side form, means like this. This equation can be resolved to like this because the same ratio. Now substitute this ax plus by equal to z. Okay, then you will get z plus c, mz plus c, and that form can be solvable easily because from here you can find the dy by dx in form of z, then you will get z and x, then they can be separable. Okay, so let me give you example for this. So dy by dx is given this, so these are same, so let's substitute x plus 2y equal to z. It will give you 1 plus dy by 2 dy by dx equal to dz by dx. Now from here you can find the value of dy by dx in terms of dz by dx, so it will be this. Now substitute in place of dy by dx this, and here it is z minus 1, z plus 1. Now you can resolve this equation, means separate this equation in terms of x and y. How? This will be 1 upon 2 dz by dx minus 1 upon 2, it will go this side, 1 plus 1 upon 2, and then dx will came out to be this. Okay, and you can solve this equation easily. How? You can use the, means you can partial fraction, means you can divide this in terms of these two, and these are constants. So let me tell you how to do that. So equate this equation as some constant a naught plus this constant divided by 3z minus 1. Now solve this and find the values of a naught and a1, just comparing. Okay, how you can compare? So a naught 3z minus a naught plus a1, and in the denominator you have 3z minus 1. So now take the z terms here and non-z terms here. Now 3a naught should be equal to 1 because coefficient is 1 and this is 1, so a1 plus minus a naught should be 1. That's how you can find the a naught and a1. So you will get something, then this will be constant. Now substitute here dz, so means in place of this you can write this whole term, and it will give you dz, some constant, and it will be 1 upon 3z minus 1, that will be log 3z minus 1, and that constant. So that how you can solve this equation now more easily by dividing this in terms of this. So you should know how to divide this partial fractions. Now let's come to the main topic, that is many questions asked from this topic, that is exact differential equation. So what is the exact differential equation? So if there is any function which is of x and y has continuous partial derivative, means the partial derivative with respect to x and with respect to y, they will be continuous. If they are continuous, then its differential can be written, can be written like this: del u by del x dx plus del u by del y dy. So it can be written like this. Now if u x y is constant, then du will be 0. So then in equation you will get 0 here. So this will be our exact differential equation. Okay, so first order differential equation of the form this is called the exact differential equation. If the form m dx plus n dy is differential of some function uxy. Okay, so this equation will be called the exact differential equation if this is of some kind this, and this is differentiation of this uxy. Okay, so just remember this. Now we will see how to solve this exact differential equation. From after just comparing with this equation, put du equal to 0, then see it will be del u by del x in place of m dx. So this m will be equal to del u by del x, and this n will be equal to del u by del y from here. Now differentiate it again with respect to y and this with respect to x. So you will get del m by del y as del square u by del x del y, and here you will get del u by del y del x. Okay, see these are both same, so del my divided by del y should be equal to del n by del x. So this is the condition for to find that if equation is exact or not. Okay, so this condition should be satisfied whether you take first with y then x the differentiation, or the first x with respect to y then y, and they should be same. Okay, so this is the condition. Now you can find the solution. How? You can find either with m or either with n. So for let's see first with m. So m is nothing but del u by del x. So take del x here this side, and here it is del u. So del u integrate will give you u, then integration of m del x will give you m dx plus some constant in terms of y. Why? Because if you now differentiate this equation with respect to x, del u by del x will give you m plus this is a function of y, then it will give you 0. So you will again get this m equal to del u by del x. So that's how you can solve this to this. And same if you want to solve with respect to n, then n equal to del u upon del y from here, and again it will give you u equal to n del y plus some function of x. Okay, and that can be again differentiate to this form. So here now you need to find the ky using this, and when you solve this you need to find that function of x with the help of this. Let's see an example, you will understand more from that how we do that. So if you want to find with n, then you will get this kind of form, and you need to find this lx, then you will get the whole solution. So there is this example: x cube plus 3xy square dx plus 3x square y plus y cube dy equal to 0. So let's say this is m, this is n. Now to verify if it is exact or not, we take del m with respect to y and del n with x, and you will see that they both are same, 6xy. Now we can say this is exact differential equation. Now how can we find the solution? We will use this equation, u equal to m dx plus ky. So u equal to m is this, dx plus ky is some function of y. So integrate this x4 by 4. Now taking y as constant, x square by 2, you will get this and ky. Now this is the solution, but we don't have ky. So how can you find ky? We can find ky with the help of the second one, n equal to del u by del y. So n equal to this. So what is n? N is this 3x square y plus y cube. So 3x square y plus y cube will be equal to this del u upon del y. So just use this and differentiate it with respect to y. You will get 0 here, and it will give you 2y, and it will give you del k by del y. So you will get this is 0. So after solving this, you will get 2 3 is 6 upon 2, it will give you 3x square y plus, now it is only the function of one variable, it will give you dk upon dy, and this del u upon del y is whole equal to n, and n is here just 3x square y plus y cube. Now from here you can find dk upon dy, that will came out to be, this will cancel out, it will be y cube. So you will always get this one in terms of only one variable, because it is exact equation, otherwise it won't be exact. Okay, from here you can find the ky, that will be a normal integration y4 by 4 plus c constant. So now you have ky, and you have this solution, and you don't have this ky, so you just substitute from here this ky, y4 upon 4 plus c dash. So you will get the solution uxy equal to x4 by 4, this term, plus ky is this. So this is your solution, where uxy is some constant, so you can take this constant also this side, and this whole term will be equal to constant. Now you will get the same solution if you start with this u equal to n dy plus lx, then use the m to find the lx, and you will get the same answer. Try to solve this equation with the help of this condition, you will get the same solution. Now to verify if it is a solution of a exact differential equation, you can just take the differentiation of u, or this you can solve this with respect to x, means take the dy over dx for this whole equation, and you will again get this. Let me show you something here. I just differentiated this whole equation with respect to x, and you again get something like this equal to 0, and just after separating or rearranging them, you can get this differential equation, and this is exact differential equation which we just solved. So okay, let's stop here, and we will move forward in the next lecture. Thank you everyone.